this presentation is just a prototype, not the final. So it may be unpleasant because there are lots of words. So let me apologize about this. So this is Junwon Baek from Gwayeong High School, and I'm really pleased. It's my honor to report about this topic, clean glasses approach. So this is the index of my presentation. First problem, second introduction, third background theory, fourth implication and hypothesis, fifth method of experiment, sixth analysis, and lastly conclusion. So problem clean glasses support is put a thin layer of water between two sheets of glass and try to separate them. Investigate the parameters affecting the required force. So introduction is when a drop of water is placed between two sheets of glass, it becomes the factor that makes force which keeps glasses from being pulled apart. So I'm going to investigate the interrelation between correlation between the surface and the force and other external factors that have an impact on this phenomenon. So background theory, first is the surface tension. Surface tension is the elastic tendency of the fluid surface which makes the required glass surface area possible. Surface tension is usually represented by the symbol. Its unit is joule per meter squared. So this is the formula of gamma which represents the force of surface tension. The hydrogen bond is the electrostatic attraction between two polar groups that occurs when a hydrogen atom covalently bound to a highly electronegative atom such as nitrogen or oxygen experiences the electrostatic field, not a highly electronegative atom nearby. Next, capillary action. Capillary action is the ability of fluid to flow in narrow spaces without any outer force. This occurs because the adhesive force is stronger than cohesive force. The height of the liquid column is given by this 2 gamma cosine theta divided by rho g r. So the explanation is like this. Next, and this is the graph which is explaining the correlation between water height and capillary diameter. Next, adhesive force is the tendency of dissimilar particles or surfaces to cling to one another. This force that causes adhesion and cohesion can be divided into several types. The intermolecular forces responsible for the function of various kinds of stickers and the sticky tape fall into the categories of chemical adhesion, dispersive adhesion, and diffusive adhesion. In addition to the cumulative magnitudes of these intermolecular forces, there are certain emergent mechanical effects. Cohesive force. Cohesive force is a force of attraction between the molecules of the same substance. It's generally much stronger when it is in liquid. Next. So this is the figure that stating about is a cohesion and adhesion. So this is my hypothesis. First, tension will increase in direct proportion as the size of the glasses increases gradually. Second, as the mass of water increases, forces increase gradually. Next. So this is the method of my experiment. I designed like this. So I put spring. This is not a spring, just the thread, and I put spring in downside, and those are the sheets of glasses. And I put a drop of water in this layer. Next. So I prepared three sort of glasses. First one is 100 millimeter square, and this one is 200 millimeter squares, and those are the 3 millimeter squares. So this length is 10 millimeters, and this one is root 루트라고 합니다.
루트라고 하면 돼.
Root 2 root 2 10 multiple root 2 millimeters, and that is 10 multiple root 3 millimeters. Next.
스퀘어드라고 해도 되고 루트라고 해도 돼.
So we measure the tension by using spring balance when we apart two sheets of glasses. The results are marked below. Next. So this is the table which is stating the experimental results, and I conducted each experiment in 10 times, and I calculated the mean value of it. Okay. Next. And this is the graph stating the mean value of first primary experiments, and secondary experiments, and third experiments. So we can see the forces dramatically increases when the surface of glasses increases in direct proportion. Okay. Next. And this is the experiment figure just regarded. Next. So we can figure out that meter per millimeter square is the most higher when the experiment third. I mean 173 by 173, 5 milliliter of water. Through this, we can estimate that the proper amount of water creates the strongest force between glasses. So I conducted another experiment. So this time, the surface of glasses is fixed, and the amount of water becomes more varied. Next. So this is the secondary experiment. At this time, I fixed the surface of the glasses, and I more varied the amounts of water in this like this. The gap was 2 millimeters, and namely, I conducted each experiment in 10 times, and I calculated the mean value. So this is the graph that's stating the force of each experiment, and this one is designed by mean value, and we can find out that at this time the force is most strong. The force is the strongest one is this. Next. Through those two kinds of experiments, we can figure out that there exists the most proper ratio between surface of the glass and the amount of water. The table above states that the strongest force is created when the amount of water is 11 millimeters. While the surface of glasses is 173 millimeters by 173 millimeters. So we can calculate the most proper ratio as beneath. This is the result value I calculated. Next. Conclusion. Through those experiments we conducted, the major thing that we figured out is that the cohesion and adhesion is greatly affected by the water, and there is the finest ratio that makes the force much stronger as we anticipated in our hypothesis. So the hypothesis 1, the shape, is correct. But the anticipation that the force will increase in direct proportion as the surface of glass and the water amounts increases was wrong. Actually, the force increases as the water amounts and the surface of glass increases, but it's not eternal. In other words, there is a critical point of conditions that makes the force strongest, and if we exceeded it, the force better gradually decrease. Thank you for listening.
오케이. 수고했어. 지금 몇 분이냐면